Okay, I'll get started with my spiel as other people pop in. I think most of you know me. I'm Julia King, the Communications Manager with the Vermont Association of Conservation Districts. Normally, these VAWQP Conservation Lunch and Learns are hosted by Allie Wells, the VAC coordinator. She's not able to be with us today, so I'm going to try to do the best I can. I'm going to share a few slides just about the partnership. Let's see. Hopefully everyone can see that. So Vermont Agricultural Water Quality Partnership. Uh, you can find our strategic plan on the VAWQP website. Here's just a quick overview and some nice photos from that plan. And then in the partnership, we do have our 9 different members from both state and federal partners. So we appreciate everyone that's part of the partnership and allows us to bring programs like this. And I'll get out of that. Oh, I think I have to stop sharing. Okay. Uh, just a quick plug, the annual meeting is coming up at the end of this month on March 31st. Registration did close, but we have some wiggle room. So if you're still interested in going, send me an email and I can get you added to the list. So with that, I will pass it on to Matt, who's going to give us an overview of data management with GIS today.
Thank you. Just gonna share my screen real quick. All right, can you all see that screen right there?
I can
That's
see it.
webinar number 2. Great. All right, so yeah, I'm Matt Marcelino. I am the GIS specialist with VACD, and today I'm gonna be giving a presentation on getting started with data management in GIS. It's probably one of the most important things one of the most important foundational things that you can do in GIS is have that understanding of data management. So, yeah, because GIS data is the foundation for any map, app, or analytical tool that you or your team creates, you're going to be working with a lot of data. So today we're going to talk about what spatial data is, how it's different from other data, how it's structured, stored, and accessed. And I'm also hoping that this webinar answers any questions regarding the basics of data management and just provides a really comprehensive introduction to GIS data. I apologize if my voice breaks a little bit. I'm just getting over sickness, so hopefully that won't be an issue. So, yep, the goals are to identify the key characteristics of GIS data, as well as identify ways that GIS data is stored and accessed. So, every GIS dataset includes a spatial component. So this spatial component allows users to analyze and visualize events, phenomena, as well as measured data. And the spatial components of GIS data allows you to perform many tasks, including visualizing real-world information and analytical output, implementing analytical framework or implementing analytical functions such as proximity analyses, buffering, and movement, as well as selecting and filtering features geographically and calculating properties such as length and area. So it's a really powerful type of data. I'm just going to give a few brief examples of GIS spatial data. So it can be visualized for a particular theme or function. So this map right here is just showing parcel values by using these different colors to represent the different values of particular parcels. Additionally, you can do things like proximity analysis, where you can find all the farmers markets close to a point on the map. This is what this is showing, as well as doing more advanced versions of proximity analyses, where you can track the travel patterns of workers through various geographic territories. Another good example can show is that you can show selected records from specific districts or even areas within inside of a district, and you're also able to use that spatial data to create things like um, these types of figures and charts and stuff of that sort as well. And this in this example, this is just showing that acreage in a fallow field can also be measured. So you can do a lot of really great things with spatial data inside of ArcGIS. However, before you use spatial data, you should know the differences between the different types of spatial data. So GIS data can be classified in several ways, but there are really two main types. That's raster and vector data. So these data types require different data management techniques and allow for different analysis capabilities. So vector data, it's composed of points, lines, and polygons, and that's probably the type of data that most people work with the most. Whereas raster data is composed of grids of cells with each cell containing a value for a particular phenomena or observation. So that's going to be things like land cover data sets a lot of times. And ultimately, what two types of data, these two data type sets are ultimately doing is they're giving you a representation of real world data that you can actually use to make or use to do analyses. So let's talk about vector data a little more in depth now. So it's composed of geometry and attributes. So geometry can be points, lines, or polygons that are representing real world features, whereas attributes provide the information about these real world features. In this example here, you can see on the left, there's a real world example, heavy air quotations, of a building and a road and a telephone pole. And then on the right hand side on the map, it has transformed that real world data into vector data. So the building is represented by a polygon, the road is now being represented by a line, and the telephone pole is now being represented by a point. So points are probably the most basic type of vector data in GIS. And this map right here, it's a little hard to see, but there's these green points in Winooski, and each of these points is depicting a tree in Winooski. So each point has attributes that describe the associated tree, such as what species it is, the diameter it has, as well as its condition. It also has other field or other attribute information inside of it as well. But I think the key thing to note is you can put that attribute information associated with each of those points inside of GIS and use it for your analyses. So it gives you a lot of flexibility of and a lot of power to do your analyses or just to see what is occurring within an area. The next vector data type are lines, and line features are using a set of vertices to draw each line. So this map right here depicts rivers. This is the Huntington River that is highlighted, and they're represented by lines that describe the stream order, the stream name, so on and so forth. So once again, you can have a lot of information associated with each of your vector lines as well. And then the last vector data type is polygons. And like line feature, polygon features use a set of vertices to draw each shape as well. So the main difference, though, is that the lines created by a set of vertices are closed for the polygon features, whereas with a line, they're not closed. And this is just a map of polygons that represent crop types in Addison County. And if you click on any of these polygons, you can see things. In this example, like I said, the crop type, you can see the length of the vertices, so the outside line, and you can also see the shape area. So we just talked about vector data. Um, the next data type we're going to talk about is raster data, and it's just a grid or matrix of uniformly sized cells that contains a value. And they're primarily used to map continuous phenomena such as elevation, air pressure, temperature, so on and so forth, which you can see here. However, they can be used to map other things as well. Most of the time, I feel like most people are most exposed to elevation raster data sets, slope, and aspect, but you can use it for a lot of different things. In ArcGIS, you can also create this thing called a derived raster product that adds context and value to your raster. And it's typically higher resolution than some of the more basic raster products. This is an example of that. This is a higher resolution raster that contains values for blue spotted salamander habitat suitability in Vermont. And basically, how I created this was by combining different raster data sets to get this derived raster. The great thing about rasters too is they can also display discrete phenomena such as scan maps or satellite imagery. And imagery and color photographs have multiple bands of data, so typically red, green, and blue. And what happens with these bands of color these is that they help produce a photorealistic image that can be used as a map, or you can use to do any type of analyses that you are capable of doing within GIS. So it's a really valuable ability with GIS and ArcGIS in particular is that you can use real world imagery. Okay, so we talked about the two data types briefly, but a core characteristic of GIS is that it describes and records spatial phenomena. So whether that data is a raster or a vector, it's going to use a coordinate system. So it uses a pair of X, Y coordinates to denote location based on a particular coordinate system. So coordinate systems are really, really important when you're working inside of GIS because they set they allow for you to accurately predict or display where your data is supposed to be on a map. So essentially, a coordinate system is just a set of geographic grids that provides a structured way of communicating geographic location. And it's typically represented as latitude and longitude within GIS. So this is a map of Crater Lake, Oregon. And the starred location is denoted as being 42.944 and negative 122.172. So those are the coordinates. So for these XY coordinates to have meeting, the data set requires a defined coordinate system that determines the latitude and the longitude values. So this map is using a geographic coordinate system called the North American Datum 1927 or NAD 1927. So whenever you're working with your data inside of ArcGIS, you always want to make sure that your coordinate systems are the same for each one of your layers. And depending on where you're working, you're probably going to want to use a very specific coordinate system. In Vermont, we have specific coordinate systems that are specific to Vermont as well. So I'm not going to talk about that today, but that's one thing to keep in mind. So in a coordinate system that is tailored to a particular area, like I was just saying, you can use the US state plane. Vermont has the state plane as well. And basically, if you're going from the NAD 1927 in this example to the US state plane, you're going to have different coordinate values. So instead of having that 42.944, you're going to have coordinates that are going to be identified as 1,552,428 feet east to 4,690 or 4,694 or 46,000 469,340 feet. Sorry about that. My brain is not working properly, apparently. North. And in this map, this data set is using the NAD 1927 state plane Oregon South Zone 3,602 map. So the benefit of using these more localized coordinate systems is that they're going to result in higher accuracy of locations for an intended area. So as I said, in Vermont, we have a state plane map as well, which is our coordinate system that is going to use the NAD 1983 Vermont state plane. So that's one thing to keep in mind. And then the last major coordinate system that you may see is the Universal Transverse Mercator, or UTM. And this one is more commonly used by the US military and other and sometimes in federal agencies. But once again, the actual values for the coordinates is going to change in this circumstance as well. So you got to make sure you are aware of your coordinate systems that you are using to assign to your data. So coordinate systems are important. And data type is important, but metadata is also very, very important. So, for example, you may need to gather data sets to perform a particular task. So you're going to need to know if a data set is appropriate for your needs. So to accomplish this, the first step you're going to take is going to view the data set's metadata. So metadata includes information that makes it easier to search for and discover appropriate data. It's essentially a description of the data or content and its intended use. So it's going to have things like the author, the date that the data was made and modified, as well as descriptive tags. So I think this figure on the right here really is a good representation of what it is, what metadata is. So metadata is, or your data is your treasure, and your metadata is essentially your map to that treasure. So it's very, very, very important. And complete metadata typically indicates that the source data is or content is of high quality. It's not always the case. Sometimes people are really good at metadata and they don't produce very good data products. But generally speaking, I would say it's a pretty good rule. If there is an appropriate amount of metadata, it's probably high quality data. Whereas if it's incomplete or lacking, it could indicate that it's derivative, which isn't necessarily an issue depending on your issue, or it's incomplete content or data. So it's really important that any data that you create or manage, you should have metadata that is as complete as possible, because if you want to, one, be able to easily describe your data, and also make it more easily shareable, and so people know how to use your data, how it was created, and so on and so forth. So this is just an example of what metadata looks like sometimes. So this table is displaying metadata for some raster data for a raster layer, and the source of the data is the Sentinel-2 satellite, and this data set is just something that I found on Esri that has a good amount of metadata. So um, basically, what we can see here is that if you need an authoritative, recently collected um, data on land cover, this data set might be an appropriate choice because you can see that it was updated on the left there. Let me see if I can use a pointer. You can see that it's been updated relatively recently, even though it was created back in 2018. However, its pixel dimensions are listed as 10 meters. I don't know if I captured that in the table. There, so looking for things like pixel dimensions when you're working with raster data may be important as well because of you may need to have more granular data for your analyses, whereas something that's big like 10 meters may not work, whereas maybe you need something like, I don't know, a couple within a couple centimeters. So regardless of what resolution you need, you can find stuff like that within the metadata, and you can quickly assess whether or not a data set is what you actually need before you start going through analyses and spending a lot of time on your analyses using the wrong data set. So I guess what I'm trying to get at is that metadata is really important, and you should be concerned with producing appropriate metadata with your data creation, as well as reading the metadata of the layers that you are intending to use.
Is it okay if I ask a quick question?
Sure.
Is there a way to see the metadata through ARC? So say you're given a layer and you want to check the metadata of that layer. Is there a way to check that through ARC, or do you need to go back to the source that gave you that layer and ask for the metadata?
You should be able to see it under the properties
Okay.
within ARC GIS. Definitely within Pro, but you can usually see it within there. Otherwise, if you go to ArcGIS online, usually that's a really easy way to see what the metadata is as well before you even download that data. But if you're using like the portal through ArcGIS, you can look at the properties and stuff like that and see the metadata if it's there.
Awesome. Thank you.
Yeah, thanks for the question. Okay. So let's talk a little bit about some common geospatial editing tasks, because in GIS, data editing is a core function. So users can create new features, you can modify existing features, and you can delete features. So you can modify both a feature's geometry, so by manipulating vertices, so you can change the shape of your data if it is a shapefile, and you can also modify its attributes. So the pictures on the right here on top, you can see that I was manipulating the line to match the road, whereas on the bottom, from this example, the name attribute is being changed within side of ArcGIS Pro. So the nice thing about using ArcGIS is that regardless if you're using Pro or online or mobile apps, you can usually edit data as long as it is editable data. On top of that, the nice thing about ArcGIS as well is that the dataset's creator and its administrators control who has permission to create, modify, or delete features. So as long as you choose your permissions appropriately, you're not going to have to worry about somebody who isn't allowed to edit data, deleting data, or modifying it in any way. On top of that, let's talk a little bit about maintaining data integrity, because this can also help prevent people from inadvertently deleting things that shouldn't be deleted, or putting in data that is appropriate for what you're looking for. So, as I said, a datasets creator controls who can create or edit a dataset, as well as how those features are created and edited. So, you can minimize the potential for errors by employing the following data behaviors, which we'll talk about in depth. So, things like domains, subtypes, topology, as well as archiving data. So, the first thing we're going to talk about briefly are domains. And essentially, you can use domains to constrain the valid values for a particular field. So, attribute domains allow you to set a list of options that help prevent errors being introduced when users add or edit attribute values. So, ultimately, using domains also helps streamline data editing. So essentially, if you're using a domain, like you can see here in this table, you can control what data can be input into each of your fields. So in this example, you're seeing that the options would be employees, maintenance, public, or security. So in the case of maybe you're working on trees and you're only interested in specific tree types, you could always put things like, I don't know, maple, uh, red oak, so on and so forth. So it's a really great and powerful way of maintaining the functionality or the integrity of your data, especially when you're not the only one inputting data as well. The next method is using subtypes. And subtypes are a subset of features that share the same attributes. So an example could be the streets in a street layer, where you could where they could be categorized into three subtypes. So local, in this example, collector, and arterial in this table. And you could assign a local street subtype to be defined by whatever or it can be defined. So in this example, if you're using a local street, as long as you put in the local street as the option, the speed limit is always going to be 35 when it's added to the feature class. So it's automatically going to set that field to 35 based on that subtype's defined value. This one is another great thing. It's not used as commonly in my experience, but topology essentially is a mathematical discipline that originated in the early part of the 20th century. It's really fascinating. I won't talk about it, but it can be thought of as connectedness, adjacency, and proximity between features. So it allows you to define the spatial relationship you want protected in your GIS data. So by doing this, no matter how much you edit, twist, bend, or squash your feature data, the features are going to stay connected to, adjacent to, or within the areas that they belong to. So it's a good way of safeguarding any potential edits in your data, or your data being edited inappropriately. And then the last great way of ensuring data integrity is archiving data. I recommend archiving data, if your personal data, if you are working on any project where you're going to be changing the data. So it's basically what you're doing is you're archiving version data, which you can think of like, an iPhone 3 versus an iPhone 4, or even like ArcGIS Pro 3.4 to ArcGIS Pro, I think it's at 3.6 now. So it allows you to really record and access changes to your data. So it allows for a lot of different things like temporal analytical capabilities by documenting data change, how data is changing over time. It can also help you answer questions like how have features changed shaped over time, such as maybe a wastewater network being reworked to accommodate road or city's growth, or how have attributes changed, such as zoning or parcel ownership. So it's a really powerful tool to see how data is changing over time, as well as ensuring that you aren't accidentally deleting your data as you go. The nice thing with ArcGIS in particular, when you are changing your data, you do have or if you're doing analyses on your data, you have the option typically to name your data sets differently pretty easily. Or if you, it's also really easy to be able to copy your data and then work on the copy of the data instead of the original data as well. Talked about ArcGIS Online a little bit ago, but the great thing about ArcGIS Online is that you, and ArcGIS in general, is that you can access your GIS and content through the website, or if you're using ArcGIS Pro, you can actually access the data from ArcGIS Pro using the portal. So within ArcGIS Online, you can create, store, and share data with groups, organizations, and the public. And it also really provides a really great library of content, including base maps, imagery, and demographic data. And it's really easy to upload data from ArcGIS Online into ArcGIS Pro and vice versa as well. So ArcGIS Online is a great place to store your data. Usually your organizations have some type of data repository within ArcGIS Online where you store your data and you can access it and use it. However, you can use non-GIS data in a GIS project as well. So what was I going to say? Not all data in Arc, or not all data used in spatial analysis is GIS data. So at the very least, it doesn't start that way. So a good example is you can map a spreadsheet if one or more of the columns in the spreadsheet contains location information such as addresses, geographic divisions like city, state, postal codes, and so on, as well as X, Y coordinates. So as long as you have that attribute data and that spatial data, you can use it inside of ArcGIS. Using a similar process, you can also integrate data from databases such as SQL. So you can, there's a lot of great functionality of using that non-GIS data within ArcGIS. The last thing I'll say about that is that you can also discover and extract coordinates, place names, and other critical information from unstructured data. So things like PDF files, reports, messages, so on and so forth. And you can then place them on a map. So it's a really, GIS is a really powerful tool. ArcGIS in particular is a very powerful tool for displaying data and analyzing data and taking things that you wouldn't think of as being spatial data and turning it into spatial data. So that's all I have for the formal slideshow. I wanted to take the rest of the time, if people wanted to look at or to answer any questions, and if anybody wanted to see how to use the GIS portal, I would be happy to show that off as well, or show you how to find the metadata. That'd be a pretty good use of time as well. I do see I have a question here real quick. How would an audio file be displayed on a map? That's a great question. I think with an audio file, it really depends. You could have it where you would click into your feature and you could have the option to play a sound, like maybe a bird sound or something like that, or you could turn your audio file into an image and have it embedded into the feature class that way as well. Does that answer that question, Lincoln?
Yeah, I think so. I was just interested to see that like moving from the unstructured data
Mm-hmm.
into the map world and wondering if like yeah, you had some sort of like audio file that somehow related to a location, you know,
Mm-hmm.
how would you show that? But um it sounds like your answer was more about embedding it in with like the metadata or having it, as part of a point or a line or a polygon.
Mm-hmm. Yeah. So
Yeah,
you need it to be associated with some type of attribute in order to display that information. And essentially, that's what I um, meant was like in particular is that you can take these data sources and you can get at it that way as well.
okay, thank you.
Yeah, no problem. Next question. Oops, sorry, my screen just disappeared.
Joanna, did you want to go off mute and share your question about controlling
Yeah,
the
so
map
I know
zoom?
it's a little cryptic in the chat. I didn't want to type a bunch of stuff when I could ask the question. So I'm kind of a beginner at both using ArcGIS desktop and online. And there are differences between the two, which can be a little
Mm-hmm.
frustrating. But what generally, when you're displaying a map, it would be really nice to be able to refine the zoom, how much the map zooms in and out, because
Mm-hmm.
especially if you're trying to capture like a screen image or do a PDF of a map or something like that, but even just to do a presentation, sometimes you just can't get it to it scrolls in, it zooms in too much or it zooms out too much. And
Mm-hmm.
being able to sort of refine the zoom would allow sometimes to be able to see the entire like map that you've created and all the features. And you can't do that. And I tried doing some research on it, and it seems like Google Maps has the same problem, and it's like a universal problem. But I was wondering if you had any secrets that maybe you could share about that.
Yeah. If you're interested in the extent of a specific feature class or subset of a feature class or whatever, you can right click on it if you're using ArcGIS Pro, and you can click Zoom to Layer, and that will get you pretty much exactly where you want to be. Or let me share my screen again real quick. I don't have a uploaded. I just was opening ArcGIS just so I could potentially show. So one thing with the zoom thing too is you can see right here, where it says that one colon 714809. Let's say you can always use this to manipulate how you zoom in and out, and you can actually use this to get to whatever values you wanted. So if I did 40,000, I can zoom in like that. So you do have a lot of ability if to choose how much you have zoomed in. Within ArcGIS Pro, you do have a lot of that functionality in ArcGIS Online. I'm just gonna try to add some random data.
I found that on ArcGIS Online, you can't do that. You can't like change the scale like that. So,
Mm-hmm.
and I've used ArcGIS Online. I've like exported what I've created in the desktop version so that other people could see the map, and maybe
Mm-hmm.
do some minor editing, but you don't seem to have that ability to change the scale like you do on the desktop.
Mm-hmm. Yeah, I think on ArcGIS Online you should be able to do some type of zoom to layer as well. Another thing you can use on Online and within ArcGIS Pro as well is you can use bookmarks as well. So if you can figure out the exact scale that you want, you can actually use some of those bookmarks. I'm gonna see if I can pull up that real quick as an example to control easily where you're zooming in and out of. Let me see. Share my screen again. So for example, if you created bookmarks ahead of time within ArcGIS Online, you can always um, go to your bookmarks and you can hit Benton County and it'll zoom into exactly what you want it to zoom in on. And to create these bookmarks, it's really, really, really simple. You go to whatever layer, area, whatever you want to, whatever area you're interested in, and you can zoom into whatever you want. So let's say we just wanted Battery Park of Burlington. We can do add bookmark, and you can type in something like Battery Park, and you can click add, and then let's say we want to Caledonia County, like, we want to get back to Battery Park. You can click on Battery Park, and it will zoom in exactly to the extent that you want it to. Does that answer that question a little bit? Or help at least a little bit?
Yes, I'll check it out. Thank you.
Yeah, no worries. Any other questions? Can be related to data management, ArcGIS as a whole. Cassidy, you have your hand up?
Oh, yeah, okay, cool. I figured out how to unmute myself. Hi. I had a question about, could you kind of go into like what is really the difference between the portal and Arc Pro and what is kind of like your best uses for both of those and how they differ?
So you're asking what the portal is in ArcPro, essentially. And what was the second part of the question? I'm sorry.
I'm asking, and I think this is kind of like a pretty it's probably a basic GIS question, but what is the portal versus like how is the portal different from Pro?
Oh, I see. Um, essentially what the portal is inside of ArcGIS Pro, and essentially what it's doing is it's serving as that connection between the various ArcGIS services. So essentially you're using it as a tool to, am I still sharing my screen? That is the question. I don't think.
I just see you.
Sorry, I thought I was sharing the screen the whole time. Yeah, so I'm assuming you can see this now.
Yes, yes.
So the portal is essentially being used inside of ArcGIS, and it's essentially connecting you to your content within ArcGIS Online, as well as with anything you may have favorited in there. It can connect you to various groups that you may be a part of. It can be connected to your organization, and it can also be connected to ArcGIS Online, where you can search for layers if you're interested in a specific thing. So essentially, it's just serving as that bridge between ArcGIS Pro and ArcGIS Online, and as a way of accessing data
Got
that's
it.
available to you. Does that answer that question?
It does. It does. And then kind of like the second question on top of that is so because I could either work in the portal or I could work in my Arc Pro projects. And so is one tool better than the other for certain things? Like, I mean, analysis is likely going to be like Arc Pro, but
Mhm.
if it's, yeah, what should I kind of, what type of work is best used in the portal versus what type of work is best used in Pro?
So in my opinion, I mean, it's really going to vary depending on what you're doing and what you're trying to accomplish and your comfortability with things. In my personal opinion, I recommend working in ArcGIS Pro just because it has so much more functionality. Um, and like you can do a lot of things online, but when it comes to doing analyses and even basic map editing, it's really, really much simpler, in my opinion, to do it in ArcGIS Pro. That being said, if you need things to like update immediately, working online is really great as well. Yeah, I guess in my probably slightly biased, but opinion is that Pro is honestly one of the best tools that you can use when it comes to GIS.
Okay, great. That answers both of my questions. Thank
Mhm.
you.
Great. Thanks for the question. Joanna, you have your hand up.
While you're sharing the screen, I wanted to ask about, you talked earlier about coordinate systems. And so on the left side, you have world topographic map checked. Is that considered the coordinate system? And then say you grab a shape layer map from the Vermont portal, Geographic Information System portal, and that would just sit on top of that but the base layer is the top, is like the coordinate system, and whatever layers you put on top of that have to match to the coordinate system.
So the base map, or we're saying world topographic map, that's just the base map.
Okay.
That does have its own coordinate system. However, the data that I used has a different, that I just randomly found on ArcGIS
Ah,
online very briefly,
okay.
has the NAD 1983 state plane coordinate system.
Super.
So this is essentially where you're going to find your coordinate systems, and this is the really important data. If I was to add some Vermont specific data, let's just see. I'm just going to go to ArcGIS line and look for Vermont.
I guess one of my questions is, if you're choosing layers like shape layers, should the shape layers match the coordinate system, or should you try to find a coordinate system that matches the shape layers you want to use?
I see what you're saying. So all your shape file layers should have the same coordinate system, regardless
Okay.
of what you're using. So a thing that you can do is, a lot of times, depending on who made the data, you may have different. You may have data in the same area, and even data that is very close in proximity, and even maybe the same data but in a slightly different area, and they may have a different coordinate system. So essentially what you want to do is, regardless of where you're getting the data, you want to make sure that the coordinate systems are all going to match up before doing any analyses on your data. So it doesn't necessarily mean you can't use data that has a different coordinate system. It just means you're going to have to project that data into the proper coordinate system, which you can do
Oh,
inside of ArcGIS Pro.
great. That's
So,
helpful. Thanks.
yeah, if you go to geoprocessing and project, it's really easy to do. But essentially, it's perhaps the most important thing that you're going to want to do. It's really easy using project as well, because of, if you have multiple layers within it, you can either you can choose whatever layer coordinate system that you are interested in. So for example, this layer that I loaded in somewhere in California by the looks of it, if I clicked on that, it's going to have the NAD 1983 state plane. And if I click on the current map, it's also going to have the same as the coordinate system as the first layer that you put into the map as well. So you're going to want to make sure that you have the same coordinate systems. It looks like Jim says, doesn't Pro typically do on-the-fly projection for us? I'm not entirely sure if, in my experience, ArcGIS Pro doesn't always do on-the-fly projection. If it's close, if the projection is close and related, I guess what I mean by that is with an NAD Vermont state plane and an NAD New York state plane, you might not have a lot of issues. But if the coordinate systems are vastly different, sometimes you do run into issues where you'll get some errors that the coordinate systems don't match up. When it comes to vector data, it's usually not as big of a deal, but when it comes to raster data, that's when you really start seeing a lot of those issues by not projecting your data type or your data layers into the same projection systems. So my recommendation is, if you are using data that has different projections, you should still try to you should still project them to the same coordinate system just to be safe. Does that answer both questions? Great. Awesome. And same with you, Joanna. Great. Awesome. Any other questions or concerns or anything that I can help out with in the next 7 minutes?
I'm sorry, I don't want to take up everybody's time, but I do have another question about metadata. Is that ever auto-generated, or do you always have to include that information yourself?
Sometimes metadata, certain aspects of metadata are auto-generated. For example, if you're creating something in ArcGIS, you have like the data sources, the extent, and spatial references, so on and so forth. But not all of the metadata is going to be generated. You're going to have a title automatically generated for you, but if you're interested in having tags, summaries, descriptions, credits, and use limitations, it's not going to have any of that generated automatically. You can write Python scripts to do that, but generally speaking, if you're not using Python scripts, most of your metadata is not going to be input, except for the stuff that the computer does automatically. Like I said, the coordinate systems and data sources, so on and so forth. So it is still important, especially if you're sharing it, to fill out the metadata, which is going to be, like I said, the title, tag, summary, description, credits, use limitations, so on and so forth. Basically, whatever you want to say, you're going to say in the metadata. And I would recommend creating metadata even if you're the only one who's going to be looking at that data, because in the future, maybe you haven't looked at a layer you used for, I don't know, 5 years. You don't know how you made it. You don't know what the original data source was if you created it from another layer. So it's a really good way of just making sure that you remember as well what the purpose of the data was and how you made it, as well as if you move on from a position, being able to somebody look at your metadata is really important. Cassidy's asking, what's your preferred coordinate system for Vermont? I would say the Vermont state plane. Let's see, I always forget it. I think it's 1983. I had it written down though. Let's see. I just find that one is really great because it's very specific to Vermont. So the Vermont, it's the NAD 1983 Vermont state plane. I believe that most of the data that, or most of the data that you get from Vermont, the Vermont geospatial portal. I can't remember the exact name for some reason now. Open Geodata portal is going to be in Vermont, in 1983 Vermont State Plane. But yeah, that's the one that I would prefer to use in Vermont and typically do use.
Thank you.
Mm-hmm. Any other questions? If not, that's okay too. If you have any questions in the future, always reach out to me as well.
Thanks again, Matt, for all of this. I will say, because we had to cancel last week's webinar, our last webinar is going to be next Wednesday, March 25th from 12 to 1. The same Zoom link should work. I'll send another reminder next week, and that one's going to be about getting starting with mapping, visualization, and analysis. And if you're unable to make this new date, we will be recording it just like the past two webinars, and they'll all be accessible on YouTube and the VAWQP website. So I see nothing else in the chat except people thanking Matt. So I hope everyone has a good rest of your day, and hopefully we'll see you next week.
Thank you.